Okay guys, so I had to clear out my parallelogram board, so here's part 2 of the video, and I'm going over the first 2 problems of classwork today and how exactly I want all 8 done, including the 2 that you can copy from me. Make sure you are justifying answers, make sure you are showing setup when necessary. Sometimes you don't have to show setup, but when you do, I better see it. And also, if you use a parallelogram rule, such as consecutive angles parallelogram theorem or opposite angles parallelogram theorem, make sure you write those too if you're using it. So just to remind you again, opposite angles parallelogram theorem, which you might use, okay, or consecutive angles parallelogram theorem. All right, so you might use that on the other problems for classwork. I'll let you know when we're using them. But mainly I want to focus on the 2 rhombus rules. Okay, again, the 2 rhombus rules are, in no particular order, but rhombus, diagonal, perpendicular theorem. That's the one where it's 90 in the middle. And the other rule is rhombus angle bisector theorem. And this one you're going to use more often, I would say. You're going to use it probably on every rhombus problem. This one you'll only use on the ones where it's 90 in the middle. Okay, so let's take a look. Number 1 on classwork, it starts right away. It's a rhombus, it's a parallelogram. Now, we're going to use this rule, which we use all the time. So here's number 1 in classwork that I'm posting right now. First of all, this angle is 54 degrees up here. So now I know a couple answers right away. Because this is 54, this unnamed angle here is also 54. And what is angle 2 and angle 3? I hope you said 54 at home. They are opposite angles. So angle 2 is 54. Angle 3 is 54. Now, here's what I'm going to write. Again, why are they all 54? It's because of rhombus angle bisector theorem. Okay, you need to write that theorem next to them. Otherwise, you will not get credit for this homework. So I will write, and I don't need to write it 2 times. I can just write it once. I will write rhombus angle bisector theorem, which we learned the formal name of today. So that's got to be the work. Some of you guys on last week's classwork, and I'm giving you credit, but you just had this. That is not good enough today. You need to write the theorem. Okay, second thing is, I can do a couple different things to get angle 1. I could do a triangle add up, all right, and that's probably the easiest, so I would recommend that. So I'm going to teach you that. Okay, instead I could use the parallelogram theorems, but to save time, I'm just going to do this. I'm going to do 54 plus 54 plus angle 1 equals 180. Now, I want to write what that is. So what did I just do? This is a triangle, guys, right? This is a triangle. So I'm going to write triangle angle sum theorem. And I am going to make you write that. I am going to make you write that. So be ready to write that one as well. So that says angle 1 if you can't see at home. That's a little messy. I apologize. So 54 plus 54 plus angle 1 equals 180. I'm going to distributive property first. Okay, I'm just going to add these to one side. So 54 plus 54 is 108. I bring down angle 1. Then I actually do subtraction property. Okay. And I'm going to get angle 1 equals 72 degrees. Now, It's the same thing over here. So instead of writing the whole setup again, here's what I could do. I could write same work as angle 1, period, angle 4 equals 72. Right? They both equal 72 degrees. If I want to do the work, I can, but it's the same exact setup. I also could write, hey, angle 4 equals 72 degrees because opposite angles, and if this is 72, opposite angles in a parallelogram are the same. So I could write opposite angles parallelogram theorem. I do need to justify the answer. So whether you want to do triangle angle sum again, whether you want to do something else, rhombus angle bisector, I just need to justify it. Okay, let's go down to number 2, and then I'll let you get going on this work. So, number 2 is angle 1's here, angle 4's here in the middle. This is 68 degrees, kind of hard to see on my board, I apologize. Figure is not drawn to scale. And this is a rhombus, by the way. And then 2 and 3, we don't know. So it's not going to be as much work for this one. Okay, first of all, angle 4, anytime you see an angle in the middle, you know it's 90. And that is rhombus diagonal perpendicular theorem. So I'm going to write that right away. Angle 4 equals 90 degrees. And I'm going to write right next to it, rhombus diagonal perpendicular theorem. Okay, so that's my one answer to number 4. I need to justify every angle on there. If I don't, you're getting a 0 on that problem. So that's the first thing. So this is 90. Now, I might use it, I might not even have to. Angle 2 and 3, if this is 68, right? Angle 2 is 68. And unlike a regular parallelogram, 3 is also going to be 68. Okay? So angle 2 equals 68, there is no work to show. Angle 3 equals 68, there is no work to show. It's just me knowing the theorem. 68, 68, 68, 68. And next to it, I'm going to write this one, rhombus angle bisector. And we will use that probably on pretty much every rhombus question. Rhombus angle bisector theorem, which basically states the diagonals of a rhombus are an angle bisector. Okay, then lastly, okay, if this is 68, right guys, and this is 90, I can just do a triangle angle sum to get angle 1. So I would recommend that. So I would write triangle angle sum theorem and start using that a lot for these rhombus problems. And I'd say angle 1 plus 90, which is in the middle, right? I know it's not angle 4, but they're all 90 in the middle. Plus 68. I think that'll be the least amount of work for you if you can realize that, hey, it's just a triangle problem. So when I add this, 90 plus 68 is 158. So there's my theorem to my answer here. And then angle 1, after I do subtraction property, angle 1 is going to be 22 degrees. So I'll write 22 degrees. Triangle angle sum is the work I have. You could have a slightly different theorem than me on that one depending on how you set it up, but that's the least amount of work. Okay, I hope these videos helped. Please take into account if you have to watch them twice to understand, watch them twice to understand, and then email me if you have any questions about the other 6 problems. But this is the work you need. You need this much work for each problem. Okay, so take your time. You have multiple days to do it, but try to get it done by tomorrow. If you try to do it Friday morning, you're not going to have time to ask questions for me, and then you're going to be lost for the quiz. So make sure you take this seriously. That's all the work you need for 1, at least, and that's all the work you need for 2, okay? And this is the shortest amount of work. So make sure you are writing out the theorems and email me if you have any questions. All right, guys. I'll see you later.